Earlier we saw that the Precharge controller here wasn't able to start up the motor on its own, so it's come time to fix that. And the current planned fix right now is a two-pronged approach. The first part being to take these 51 ohm resistors out and install these 36 ohm resistors, which will increase the precharge current and therefore reduce the voltage difference at the end of the precharge. The other thing is that this resistor here, labeled 683, is going to get replaced with a 100K, where it's a 68K now. And that will increase the threshold at which the precharge controller will be satisfied that the precharge is complete. The issue with the resistor replacement is that this solid state relay thing there, it has a limited current handling capacity, and it's already kind of near the limit for continuous duty use. But given the fact that the precharge occurs really fast and the current through it drops off from the maximum pretty quick as the capacitors charge up, I've looked at the curves for what the allowable current in time is, and I think that with these resistors it'll still be safe. But just in case, I've also got a handful of these little fuses, which should blow just before that part would. And since that part's like quite expensive, I figure putting one of those in there won't hurt, and I think I can manage to make one fit kind of in this space here in series with the resistors. That way, if it blows, the charge controller will see suddenly that there's the maximum battery voltage on there, and it'll choose to not close the contactor and instead declare the precharge has failed. The manufacturer of these precharge boards was so kind as to release the schematics for them a couple months ago. So I'll take a moment to better explain what I've done and why. So here we have a simplified schematic of the car where we've got a battery, a switch, and a motor. So obviously this motor isn't just a motor, it's got an inverter and transistors and all that other stuff. And one of the things it has in there is a bunch of capacitors that are just important to help smooth out the DC input to the motor. And here we've got the switch. So this is the switch that controls power to the motor. There's other stuff connected to the battery, but that's not important. What is important is that when this motor is just sitting, the capacitors inside, which are like that, discharge. And if you want to switch the motor on, you have to charge those up first, because if you just close this switch, which can handle, this switch can potentially put out thousands of amps when you close it, and if those capacitors are discharged, it will do so, and that will damage things. Very expensive, a lot of very expensive stuff that I'd have to replace, or best case, it would probably just weld that shut and I wouldn't be able to shut it off. So what this circuit up here does is you connect these up across the switch. So here we've got another kind of switch, which is just a solid state sort of thing. And when you want to start up the car, this switch engages. The current flows through here, through the switch. I might have this backwards, but through the switch, then through these two things, which are the big power resistors. And this black box there is the switch. Comes around, and then here, and then that's what charges up the capacitor. So you've got these resistors here, which are basically what sets how much current is allowed to pass in there so that the capacitor can slowly charge. And you've got this opto-isolator here, which is used to sense when the precharge is actually complete. So one problem is that since the motor has a bunch of electronics in it, as this thing is trying to charge up the capacitors, the motor starts to draw a little bit of current. And what's happening is that the current that this draws when it's idle is high enough that the opto-isolator tells the microcontroller that the capacitor is not yet fully charged, so it won't close the switch. So what I've done, these two resistors, which are those, I've gone ahead and replaced those with a lower resistance so that way more current can flow with the same voltage drop. And then my next step, which I haven't done yet, is to replace this resistor here, which sets at what point this will turn on and off. and that's how the microcontroller decides whether or not this is sufficiently charged. The current setting is a little bit conservative just to prolong the contactor life, but I think with these being new and my contactor being a good one, it can handle a little bit more. I contacted the manufacturer of this, and that was their advice, was to tweak this a little bit to get a higher threshold since I'm having problems. What I've also gone and done with this fuse is that this resistor here, this leg of it, goes into a PCB trace, which goes from here under the board to here. So I've cut that, and in its place installed a fuse. That's not a very good schematic for a fuse, but I've installed a fuse there, and that will hopefully protect this device and these resistors in the event that this is just not a good idea and it pulls too much current. So as one final step, I learned that the fuse actually does poke about 1 millimeter above the top of the resistor. So I've had to carve out this little channel in the case. Now this is just a 3D printed plastic part, so I started dremeling right through it. If I went all the way through, then I can 3D print another one. I did have to spend a little time. I put a little grease along the top of the fuse and closed up the case to see where the grease got deposited. And after a few rounds of that, this is the channel I came up with. And all I did was just run in there with a Dremel with a grinding wheel on it. Alright, so here we are about to test the Precharger. So what's going to happen is I'll turn everything on. Dad will be calling out the status of the Precharger's LED. I've got a voltmeter set up elsewhere to watch to see what it's doing. And hopefully, with the adjustments that I've made to it, it'll actually be able to engage the motor. Alright, so we've got the full 356 volts across the motor contactor. And here we go.
Red, green.
Alright, so that, I think that worked. Alright, I'm going to go
I
again.
didn't hear a secondary click.
I know. Hold on. I'm going to go again.
Red, green,
Now what?
green.
Huh. Okay. So actually I didn't connect the other contactor yet because I wanted to see if that would actually do the thing. So now that it's acting roughly correctly, I'll hook that up and we can try it again. Alright, here we go with the second test. I've connected the motor contactor to the output of the Precharger's coil contacts. So when I switch everything on, it should engage the motor.
Green, red, click.
Nice.
Sorry, red, green, click.
Yep. So now, brake input, drive input. Brake input, drive input. I didn't like that. Brake input, drive input. Nope. I'll have to figure out why that didn't work. Alright, so we're going to test now the Precharger with the actual contactor hooked up. I forgot to hook up this thing as well last time, the 057 converter box, and that's why it didn't drive. So now that I've got that hooked up, everything should work. So, main contactor, motor 12 volt, and then motor contactor.
Green, contactor.
Cool. So now brake input, drive input, and it creeps. Neutral input and it stops. Brake input, reverse input, and it creeps again. So we can also check that the rear brakes are working like this. So Dad's applying them now. Up, down, up, down, neutral. All right. So that's all working. Turn the contactors off. So now that the Precharger is able to actually precharge on its own, that's just another thing off the list before I can send it down the driveway. I'm going to cut the video off here, so thank you all for watching, and I'll see you in the next one.